Hello, everyone. This is your weekly dose of stats. Welcome to our second week review session of business analytics. How has everyone been doing?
We're great, Jerry. How about you?
Well, glad to hear that. So, continuing from last week, we are diving deeper in descriptive statistics. This is what we have learned in this new week. Are there any questions regarding descriptive statistics so far?
Jerry, I have a question. This is Tiffany.
Hi, Tiffany.
For some of the equations that distinguish between sample and population,
Okay.
Professor once said that we should just assume population. Did I hear that right? Or should we be looking at the problem or the question to see like, oh, could this possibly be a sample?
Great question. We will discuss this when we discuss about the first, I believe, question for the score. Usually, what we need is from Excel is the sample deviation formula instead of the population one.
That is for the z-score, you're saying? For the z-score, you need the sample? Okay.
I think in our homework 2, that's where this difference between sample statistics and population parameters matter.
Okay. Okay, thank you.
I guess just to add on to Tiffany's question, so for this homework 1, using the population equations is the correct methodology, and we won't differentiate till the next homework assignment.
Yes. For homework 2, when we calculate these scores, we should use the sample standard deviation.
What? Okay.
Can
we unsubmit? All right, I guess let's go through it.
Did the professor suggest otherwise?
Yeah.
Oh, really?
Yes. No, we had it as population as the
population.
Yeah.
Right?
Yes.
Oh, really? Okay. That's interesting.
The
Okay.
Safety in numbers.
What? Okay. There might be a reason to do so because in the in our homework 2, the z-scores were calculated for countries, right? I don't think there's a second version. So in that situation, if we believe that we have measured all countries in this planet, then yeah, fine, if we use population standard deviation. But they only differ. I mean, the population and standard deviation formula results only differ very slightly because we have more than 200 countries and territories, so they won't really show up any substantial difference, even if you use either of them. Okay. So this week, we have learned about descriptive statistics. We have learned about different types of data. And there's a distinction between population parameters and sample statistics. We have also learned a few ways to modify the data, continuing from last week by sorting and filtering the data. And we have also learned about distributions, measures of location and variability, and some ways to analyze distributions, including a z-score. which was included in some of our homework questions. And we also learned ways to assess association between variables. Are there any questions regarding the content of the second week learning before we, okay.
Jerry, do you mind kind of talking a little more about z-scores and exactly what a z-score means relevant to other data?
Oh, wonderful. How about we use examples to illustrate what these scores mean? Let's see. Let me, oh, okay. Go to my notes. You can also follow the notes from the TA Office Hour tab in the Canvas website. So in homework 2, one of the important content and skills we learned are about these scores. There are a few topics I would like to discuss. So first is how to use Excel formula to calculate these scores. Has anyone encountered any difficulty while doing this?
It is data value minus mean divided by standard deviation of the population, right?
Yeah, sounds good.
Okay.
But I would like to point out that we do need to take some caution while calculating that. First is the distinction between a relative and absolute cell reference. Second is we also need to mind the priority of arithmetic operations by using parentheses, for example. And another distinction is whether we should use the populational standard deviation formula. Let's address each of them. So in our homework 2, I believe it was the first question. It already requests the calculation of a z-score. So original data were given by country and by the number of total cases, the number of total deaths, and population size of each country. So in total, there are 50 countries listed. Okay, so to calculate a z-score, for example, a z-score is specific to a specific variable and a specific case. So we can calculate a z-score for all these 3 variables from the original data and for each of the 50 countries and regions. So as the last student indicated, a z-score is simply defined as the original score, which is this much highlighted here, minus the mean value. The mean value is given in here, basically the average, divided by the standard deviation. Here is the standard deviation. So I would like to point out first is that there's cell reference here. A cell reference, when it does not have any $signs, is a relative reference. It means that when you drag this autofill, you will notice that on the second row, the C2 becomes C3 because the row moves downward by 1. And if we click to another row, for example, on row 33, we notice that this first cell is already C33. So the reference total case becomes, well, the observation of the total case becomes this one instead of previously as highlighted in this cell, which would be the second row. So in contrast, there's also absolute reference. We can absolutely reference a row or a column or both a row and a column. For example, when we talk about total cases, the sample mean value or the average value was calculated here using the average function. This is how the average was defined by, let me enlarge my screen so you can see it clearly. So the average is calculated at the average of all the 50 countries and regions in terms of total cases, right? So when we calculate a z-score, we want to make sure that this average value or the mean stays the same when we calculate a z-score for the total cases across all the 50 countries and regions. For example, if we move to another row of z-score of total case, we still notice that this mean value is still C53, which is here. It does not change when we autofill this formula to other countries. Similarly, this standard deviation does not change when we move from one country to another. That's why we use a $sign to designate absolute reference to the row number. We did not, I did not use absolute reference to on the column because I would also like to calculate the use the same mean and standard deviation for total depths. That's why if I move this first, if I autofill this calculation for total case to total depths and using autofill, we notice that it still applies because or the column which was originally C is now changed to D because of the relative reference. Because originally the data was stored also by adjacent columns. So that's why while using autofill, it also does so. So here on this column of total depth, these scores, I'm using the individual observations of total depths relative to the average of total depths and the standard deviation of total depths all are highlighted. Did you use the same way as what I did?
Sure, I put it in the chat, the formula I used. Luckily for me, we got the same answers, but that's what that was in the video, is the standardized formula.
Yes,
and then
correct.
Embedding, okay.
Wonderful. Here I'm using this way to specifically show what the standardized formula does. It's basically to subtract the mean value, then divide by the standard deviation. So here I would also like to follow up with the distinction and caveat about priority of arithmetic operation. It basically means that the operation in Excel would put priority on powers, then on division or multiplication. Oh, okay. Division or multiplication is the star function. Okay, then it will consider plus or minus. So, which is why here, when calculating these scores, I had to use a parenthesis to protect this subtraction before doing a division. Otherwise, for example, if I remove this parenthesis, you will notice it's different. So the correct way to calculate z-score would result in 5.05, right? If I did not use parentheses, it's different. It will give me like 100,000, more than that. So which is why it's important to use parentheses when it's necessary. So that's first step about z-scores. Now let's have some extended questions regarding z-scores. Okay, so first to note is that a z-score is for an individual observation. So there's one specific country corresponding to a z-score. And as I said, it's also specific to a variable. So it's meaningful to, if we talk about a country, if we talk about a z-score value specific to a country. So now it comes to a question, how to interpret a z-score? Any tentative answers? So for example, I would like a volunteer to interpret what this value of 5.42 means.
Okay, I'll take a crack at this, Jerry. This is Ben.
Great. Ben, oh, nice.
I think that it means that it's about 5.4 above the standard, or standard deviations above the mean.
Wonderful. The way to interpret a z-score is simply according to its formula. Because we calculated a z-score by subtracting the mean from an observation, then divide by the variable's standard deviation. So when interpreting a z-score, we also do it from what it shows according to the formula. So as Ben suggested, a value of z-score like 5.42 means that on the scale of standard deviation, USA on this first row is 5.42 standard deviation above the mean. So we can also make it more specific in terms of what we meant by standard deviation and mean by substituting for it. So here we could say that USA has a number of total cases, which is 5.42 times of standard deviation, which is this much. We can find out more about how much it is by giving it a, wow, well, it's a lot. It looks like it's 16 million. So 5.42 standard deviation of 16 million above the mean, which is 11 million. All right. Now we know how to interpret a z-score.
But Jerry, would my answer suffice, or would I need to add more?
Your answer is correct. So I'm just adding some more details in terms of what we meant by standard deviation and mean. So another good use, so what's the benefit of transforming original scores to z-score instead of just using the raw total cases? So from this formula of calculating a z-score, we note that it's quite obvious to interpret, to tell from a z-score whether an observation is above or below the mean. So from here, we know that USA has comparatively a higher number of total cases compared to the average of all the 50 countries. Instead, if we go to another country, for example, Australia, which is negative 0.39, below zero, we immediately know that this original count of total cases, which is slightly above 5 million, is less than the average of total cases across the 50 countries. Okay.
Question for you, Jerry.
Okay.
I'm back to the population versus sample. So I noticed with your USA Z-score for total cases, it was a little bit higher than mine. So I use standard deviation of a sample. It looks like you use standard deviation of a population.
Yes, that's the difference. So here, if we use the standard deviation of population formula, we will have a standard deviation slightly smaller than a formula calculated using the sample formula, which will slightly change the Z-score calculated. So I think the reason why our professor used the population standard deviation is simply for the case of simplicity.
Okay.
In most cases, in research, in business application, we would use the sample standard deviation.
Okay, thank you.
My pleasure. Let's move on to another area about Z-scores. Okay. Oh, okay. Here is a question to challenge you. Do the Z-scores of a variable follow a standard normal distribution? Feel free to comment in the chat area. What do you think? Is this, would you say yes or no? Do the Z-scores of a variable follow a standard normal distribution?
Should be, right? Because we divide the difference by standard deviation.
Okay, one student believed yes. Are there any other thinkings?
Well, it's a unit, right? So we're creating a unit measurement, so it should, but.
Okay.
The other thing is, yeah, when you sum up a group of Z-scores for a total data set, they equal to 0. So the thought would be that they do follow a normal standard deviation distribution for that.
Oh, okay. Sarah also believed so. Simple answer is no. It depends.
Okay.
Yeah, it depends on the original distribution, which is the yeah. So okay. Let's move on to the second before I address both of them. Does transforming a variable to its Z-scores make the data approximately follow a normal distribution? And based on what I just said, the answer is also no. Because the Z-score, calculating a Z-score is simply a linear transformation. A linear transformation is basically when we use any subtraction or addition or multiply or divide the original score by constants in the form of AX plus B. So for example, in our Z-score calculation, this B would be minus mean divided by standard deviation, and this A would be the inverse of standard deviation. Doing a linear transformation, like calculating a Z-score, does not change the shape of the distribution. So it won't transform a non-normal distribution to a normal distribution. In contrast, there are also ways to transform data that's not linear. For example, if we take logarithm or take exponential of original observations, which is beyond the content of this course. However, the way to understand what Z-score transformation does is simply make a plot of the Z-score. I would leave this practice to you. So if a Z-score transformation moved the original distribution to a normal distribution, you will find that the Z-score should show a histogram of a bell curve. But if it does not, then it means that a z-score transformation won't give you a normal distribution. All right, so much about the z-score. How did everyone do when you build pivot tables? The professor also just released an announcement about how to show items with no data in pivot tables. So feel free to check out his announcement.
Question,
Oh,
was it necessary to use pivot tables at all for this homework, or could you do it with no pivot tables?
that was Ben. Great question. I will also ask other students whether you have done this homework too without using pivot table at all.
I did. I started to for the histograms, and then I just used the default. So I didn't use pivot table.
Okay, Stephen didn't use pivot table either.
So
I didn't use
But-
pivot
I-
tables.
Oh, cool.
I did use pivot tables. I tried them for the histograms and also for getting the standard deviations. And I found them both to be different than if you do not use the pivot tables.
Who made the comment?
This is Abby.
Oh, Abby. Okay, cool. So yeah, I know why you had this situation. We will discuss that right away. I noticed that there are new comments I need to follow. Let me take a look. Oh, okay, I see. There was also a question regarding tree maps and say something about scatter with smooth lines. Okay. Yeah, we will go to tree maps later. So now let's focus on pivot tables. I understand that for simple questions, like in homework 2, it's not necessary to use pivot tables. So it's quite okay if you did not use it. But for some more complex work, pivot table is usually the fastest way to give a summary table. So let's make it. Pivot table is most useful when you when we address question 2 for the COVID cases. For problem part D, when we build a histogram, the data that will be used for histogram can be generated using a pivot table. So here is a case of a pivot table. I already calculated the mortality rate here. So in pivot table, in part D, we need to build a histogram of this mortality rate.
Jerry, we're not seeing anything if you're sharing your screen or intended.
Oh, all right. Sorry, I forgot that I stopped sharing earlier. So let's move back to the screen share. Here you see that I already calculated the mortality rate as a percentage by using the number of total deaths divided by the number of total cases. The way we calculate we generate a pivot table is to go to insert pivot table. And you will put prompt to this conversation to select whether you want the pivot table to be in the same worksheet or not. So I usually use this existing worksheet and give it a location. So the new pivot table would be built here. All right, let's click OK. All right, well, I forgot to give 2 rows of a pivot table. Okay. All right. So by default, it shows nothing until we supply what needs to be built. So here we want to show the mortality rate. to give a range. So we need to drag mortality rate to both rows and values. So by default, it shows the all the unique values as a list because we had 50 different countries and regions. So that's why we see roughly 50 rows of it. So instead, how do we build a pivot table using the ranges of the mortality rate? This is done by right-click this row label on any value of it and go to group or ungroup. Or alternatively, you could move to, you can move to pivot table analyze. And there's also a way to select the group or ungroup. So here, we go to the group field. So we can let it start at 0 and ending at 0.1. Or let's see, the original, the original case wanted us to build those into 0.6 by a difference of 0.1, 0.01. Okay, so in this case, it will automatically shows us a range of this. But we noticed that there's one category missing, which is between 0.03 and 0.04. To make all these shown instead of omitting, we would have to go to pivot table options, and for the empty cells, we let it show 0. And we would also change the number shown in this column instead of sum of mortality to be the count of mortality. This is done by clicking sum of mortality, go to values, and we change from sum in value field settings to count. Then we will notice the difference. So to make the list also include the category of mortality rates between 3% to 4%, we right-click this row labels again, go to field setting. There's layout and print tab, and we check this show items with 0 data, with no data. And we will find that this row is included now. So there are students who wondered how to change these labels to percentage. Unfortunately, there's no automatic way to do so. If you want to build a chart that's appealing, then copy and paste this table as values. Then you can manually change these labels. For example, from 0.01 to 1%, then to 2%. Then you would do this to all the other rows until you are satisfied with the labels. So this is the way to build a pivot table. Are there any questions? Great. Then we can move on to other charts. Okay. In question 1, we are challenged to build a box plot. Has anyone already done so? Well, where did my, okay, box plot is here. So it's important to understand what each component of a box plot represents. So let's go through each of them. So if you enlarge it enough, you will notice that in the center of the dark box, there's a line. So what does this center line means? Any volunteers? Any tentative answers?
That's right at the mean.
That was John. A good try, but incorrect, unfortunately. The center line within this dark box is not mean, but median.
Median. Okay.
I had a 50-50 shot. Thank you, though.
Yeah, good try. So which is the why a box plot is good? No matter whether the distribution is symmetrical or not. Because we already learned in our textbook, I believe, and also the videos that when it is more appropriate to use median to represent the average or the location instead of mean. Okay, so the center line represents median. How about the top border of the box? Any tentative answers?
The range.
Is that the range? Yeah.
Unfortunately, no. The top border is known as the third quartile. Basically, it's the 75th percentile. So if we sort the, okay, here in this case, it's about price, right? If we sort the price from the smallest to the largest, you will find this top border represented by the 75th percentile. So correspondingly, the bottom border represents the first quartile or the 25th percentile. So it'll be the first, it'll be the border between the first 25% of the data. So all these three lines in the box are consecutive. So it'll be the first quartile by the bottom border, and the second quartile or the median or the 50th percentile in the middle, and the third quartile on the top border. So now we understand.
Jerry, is that, sorry, with the box and whisker plot with the quartiles there, is that standard across all box and whiskers, or would there be instances when you might want to use a z-score standard deviation based on that, or is it always quartile?
So the box plot by default is always the quartile. If there are any box plots you've seen that's not representing the quartile, it should announce so otherwise in the notes. But just as any other charts built in Excel, you can always customize what each component represents. So it's possible to change, for example, this middle line not to represent the median but mean. So it's possible to do so, but usually it's not otherwise, because your readers would automatically recognize these most common choices of representation of chart elements. So we have just discussed the three components of the box. What about the whiskers? Can one of you tell me what does this bottom line represents?
Is that the minimum?
Good try. So possible. In this case, quite likely it is the minimum. But the default choice is that this bottom line or the whisker limit would represent 1.2 of the interquartile range. So the interquartile range is about this much. So it's assessing the distance between the first and second quartile. and multiply it by 1.5. So that's why you see that this length of this vertical line is roughly 1.5 of the length between the distance between the first and the second quartile. Oh, sorry, I think I just made a mistake. Okay, talking about the interquartile range. The interquartile range, or known as IQR, that you will normally find in other menu, is the distance between the first and third quartile. So it's between the 25th and the 75th percentile. The student just now said that this might be the minimum. So it's possible because 1.2 of the width of this box is somewhat larger. 1.5 of this box width is larger than what you see here as the vertical length of this whisker, right? So in this case, the bottom line would represent the minimum. However, if we go to the top whisker, we notice that it's not representing the maximum, because the maximum is here represented by an outlier point. So in this case, this whisker does represent the distance of 1.5 of the interquartile range, which is the height or the width of this box. So now we have gone through all the 5 statistics that can be represented by a box plot. That's the minimum or the IQR, interquartile range, the first, second, third quartile, and any outliers represented by points. Are there any questions regarding a box plot?
Yeah, Jerry, one quick question on the outliers. I know the book suggests that anything that's above 3 or below -3 z-score would be considered an outlier. Does Excel use that same logic, or is there a different value that Excel uses as a limit to define an outlier?
Okay, good question. So Sarah just pointed to 2 ways of defining outliers, either by calculating z-scores and recognizing that any observations that has a z-score absolute value larger than 3, which means the z-score could be above 3 or below -3, are recognized as outliers. There's a second approach by using IQR, or this box plot. So here in the box plot, the outliers are defined to be any observations that's beyond this whiskers. So remember that the whisker was defined by 1.5 IQR, right? The IQR is the difference between the first and the third quartile. So this is the second approach of defining outliers. So you can take either of these 2, but make it clear which way you choose. And if you wondered whether there are any preference about which to choose, then you can consider this. So this box plot is okay for any type of distribution, whether it's skewed or not. But a z-score, as I mentioned earlier, it does not transform original observations to any normal distribution. So if the original observations are skewed, for example, it has many high values, then using z-scores won't change the skewness. So in that way, using z-scores to define outliers would omit some of the outliers that would possibly shown if you build box plots. So in that sense, using z-scores to define outliers might be more appropriate to the situation where the data is more symmetrical or closer to normal distribution. Okay, let's see other parts. Okay, we're close to all the major points that needs discussion. We also already built the histogram. So I already showed that the way you can adjust the output of a pivot table to include those cases that have to include categories that have zero counts. But there are also ways that you can adjust the bin intervals while building histograms. So I included this link for you to do so. Feel free to check it out. So another student asked a question and noticed the difference between the histogram built by either using the histogram chart by default or build a histogram out of a pivot table. So the disparity comes from the distinction of defining the intervals. In a pivot table, as shown here, oh, bless you. This range between 0 and 1% and the consecutive range between 1% and 2% has the property that it's inclusive.
Your text messages.
That's
that
decreased in my fucks to
Hello?
give. So between the sending the first one and the second one.
Hi, what's
Hey,
that?
mute yourself. Mute.
No, I'm over this. I'm sorry. I'm sorry. This
Was it a
TA
question?
section,
Yeah.
'cause I was going to stay till the end, but then I was like,
Hey, Lindsay.
Hey,
Lindsay,
mute.
Well,
oh, now Momo Michael is yelling.
No.
I muted her. Well, feel free to unmute yourself when you actually have a question. Yeah, I was about to show that pivot table defines an interval in a different way than histogram. When you build a pivot table like this 0 to 1%, it's inclusive on the left limit, but not inclusive on the right limit. It means that if there's any country that has 0% of mortality, it'll be in this category. But if a country has exactly 1% of mortality, it won't be in this row. It'll be in the second row. Because 1% is included as the left limit, but the right limit is included in the next category. However, on the contrary, when you build a histogram, which is done by, for example, selecting mortality and go to insert chart and histogram. If you build a histogram in this way instead of first building a pivot table, you notice that all these intervals is not inclusive on the left limit, but inclusive on the right limit. That's why building the histogram in these two ways can give you slightly different outcomes in terms of the count of observations. So a good way to check whether the plot built is correct or not is to examine the individual elements. So you could do so by recognizing whether the X and Y axes are designated as intended. If you flip the horizontal and vertical axes, sometimes it gives you a chart. Sometimes it still gives you a chart, but does not make sense. This would be more relative if you build scatter plots. On the other hand, it's also beneficial to notice the ranges in the horizontal and vertical axes. This is also relevant when you build any type of charts, including histograms. So for example, in our homework, it's required to build mortality rate between 0 and 6%, such that each category covers 1%. Then, if you build a histogram like this, it won't satisfy all the requirements, because the default way to define these intervals does not give each interval as 1%. You can change this by click this axis and right click it to format chart area. And now it's telling us that we're formatting the chart area. Specifically, we want to format the horizontal axis. Then if we go to the axis options, then there's a way that we can define the bin width. So instead of the default, let's give it 1%. And in this way, you notice that it automatically changes to 1% intervals. Sometimes the delineation between these intervals won't be exactly at this 1%, 2%. We can define a specific interval delineation by setting an underflow bin. So for example, we want to make sure that the bin would split into two exactly at 1%. So we give it at 1% again. Then this is the way that it surely gives us the bins as what we wanted. So if we did not notice this distinction, we could have ended up with this chart that did not have 3 to 4% in it. But if we rebuild our pivot table, for example, using a manual change of the labels, that's how we can have a very beautifully formatted pivot table with the percentage shown on the axis and with each bin exactly containing 1% in interval.
Jerry, if I'm
hi.
not, excuse me, yeah, if I'm not seeing bin width under my options, do I not have the right add-in?
Which chart were you talking about? Was that this one built from
Yes.
pivot table or this one built by histogram?
Well, either one. When I go to options and I'm
Okay.
kind of maximize that screen, it just says gap width. And it doesn't give me the bin options that I see on your screen.
So first we need to select the axis.
Mm-hmm.
Then right click it. There's a format axis. Do you see this option?
Yes, I do.
Okay, now here you go. Wonderful. Are there other questions about?
No, and I'm sorry, I get
Okay.
there. I get there. I just don't have it. It doesn't show on my Excel, so maybe I need to.
You don't have it. Oh, okay. I'm not sure what that means. Do you not see this format axis option?
Correct. All I see, I know I see format access. I see access options. I click on that. I see exactly what you see, except when I maximize.
Oh, okay.
Options.
So yeah, make sure you go to this symbol of access options.
No, I'm on it. It's probably my Mac. I'll look at the add-ins. It's a me thing, I think.
Then
Okay.
I don't have that either.
Oh, really? Okay.
Okay.
All right. So if you ever have questions regarding how to do certain operations in Excel, a very good way is to simply make a search. For example, I found many of the solutions by making my own searches. I had a question regarding how to set the limits. So that's how I found a way to adjust the limits in Excel. So I included all the links I found by my searches in the notes. So feel free to check them out.
Thank you.
My pleasure. So in our homework, there's also a third question, or maybe the fourth, regarding Oh, yes, it was the fourth one. Statistical lies. I included some of resources and articles I found that's interesting to read. However, it's beyond the course. It's not required content. One of the statistical lies is known as p-value hacking, also known as data snooping and dredging. So basically, it's possible that some studies or reports announce statistical significance, while it's possible that it could be a lie. There are also another series of lies by interpretation. Sometimes researchers or news reporters would mix the implications between association, correlation, and causation. So it's good to recognize their differences and distinctions. So I included a journal article and also a blog summary about the differences between these three different ways of statistical differences. There are also other common data exploration procedures I discovered, which is very useful. And if you ever need to build tables and figures that's more professional appealing, it's good to use the APA guidelines. This APA guideline is also useful when you need to report statistics using good formatting and number of digits. And I noticed that one of the students wanted to see about tree maps. What are the questions you had while building tree maps? Oh, well, let me go to the chat room.
Yeah, hi, this is Mark. How do you actually do the tree map? What selections do you use? How to insert it? Do you use insert and format?
Okay, let's demonstrate how to build a tree map then. So to build a tree map, it's important that you must have the label of country right next to the data series that you want to be shown in the tree map. So for example, if you want to build a tree map of country by mortality rates, you must move this mortality rate to right next to country. So you need to change. Oh my God. Okay, you need to change the position of the columns. So let's assume that we want to build a tree map of country by the total number of cases. We select both columns, then go to insert chart tree map. And here it goes. It gives us a tree map. Automatically, it includes a series of legends, which is redundant because we already have the country names shown in each of the rectangles. So simply we can select this legend area and click delete. Then that's how we can derive this tree map. We can, of course, change the chart title to say that it's tree map of country, total cases by country. Yeah, here you go. Did you encounter other difficulties while building tree maps? Okay, let me go to the chat room meanwhile to see whether there are any additional questions. Oh, how do you find the document I'm viewing? If you're talking about the shared notes, I have included the link to the review session notes in the Canvas tab of the TA office hour. What's the difference between Perla asked a question, but it's incomplete question. So feel free to complete the question or image yourself.
Well, Jerry, while she's coming back to her computer, I'm guessing, what's the logic on figuring out the cases per million? Because my charts, tree maps look the same on those two, and I have a feeling that is not right. Total cases and total cases per million. I may have oversimplified it.
Could you show me what chart you have?
Sorry, on the COVID-19 tab, the tree maps of total cases versus total number of cases per million.
Oh, okay. By appearance, they should be very similar, right? Are we questioned to interpret the difference in interpretation of these two?
No, mine looks similar. I just felt like I was wrong, but if you think they should look similar, then maybe I'm okay.
Yeah, it should be similar. So remember that a tree map simply shows us the relative size of the value, right? So either this relative size is, oh, okay. Am I sharing my screen? Are you seeing my shared screen?
Yes.
Oh, okay. Somehow my screen flipped. Okay, so a tree map uses the relative size of the rectangles to show the original cases, right? So either this original case was in million or in integers, they would show exactly the same relative size. So that's why it won't be a surprise if you see that a tree map built from the per million cases or not by dividing per million case, it would be similar. However, I think your case might be, the question might be more about whether we should divide the total cases by the population size instead of by 1 million. So the difference should be dramatic if you divide this total case by the population size, which varies between the countries.
Okay, but for the sake of the homework, it would have been divided by 1 million?
Let me go to the homework questions to see what it actually asks. So when it talks about million, are you talking about problem 2, part B?
I am talking about 2E.
Part E, okay. Let me see. Create tree maps for the total number of cases, the total number of cases per 1 million residents, and for the mortality rates. Yeah, so, okay, then it's not supposed to be tricky. Then I'm assuming the purpose of this question is to help you to understand what a tree map actually shows. So it's quite okay if your first 2 tree maps looks very similar.
Great, thank you so much.
Yeah, earlier I was more concerned about whether to standardize the number of cases and deaths by population size. That's where dividing the population size would definitely change the relative magnitude of either adjusted cases or fatalities. Well, we already passed.
So we don't need to
divide.
we don't need to divide by million or something, right? To show, we can just use the actual data in the tree map, right? For the homework question.
For the homework question, because it has 3 parts, it's still a good practice that you do all these procedures. Here, we just show that the tree map built by total number of cases and the total number of cases per 1 million residents would look identical, but they were built from a different series of data.
Got it.
And what's the best way to upload this homework, just as a big Excel file?
No, we are not required to upload Excel files. It's as I described in our shared note. Simply you upload a PDF format of the writing part, which should come from a Word file. Okay, I see another question. Where would you have the link to the recorded session? It's also the link would be also uploaded to our Canvas course website in a module of TA office hour. Okay, one student wanted to see how to make a line chart. What kind of difficulties have you encountered while building a line chart? I think this comes from homework question 3. Yep. So just as the way we build any other charts, we would sometimes need to copy and paste the columns again so that they are adjacent. So for example, if you want to build a line chart for the Microsoft stock price by over a time period, but notice that in original data, these two columns are not adjacent to each other. So it's necessary to make them adjacent to each other. Best way I found is simply copy and paste. So select both columns so that they are adjacent, then go to Insert, Recommended Chart, and find the one that looks most appealing to you. So for example, this one is a line chart. We can also go to the All Chart option to check each of them. So if we build a scatter plot, this is where we can find it. Notice that sometimes Excel doesn't recognize which to put on the x-axis and which to put on the y-axis. So that's why it shows you two series of data. However, this one correctly recognizes time period as the horizontal axis. So we go to line chart. That's where we should use the second one. Always remember to check what variable was used for the horizontal and vertical axis, respectively. If you used the default one, then of course it doesn't really make sense. As you can see, the period was also used as another series of data to show on both axes. So it's important to select the second one. And here you go. It's identical to the one I built earlier. All right. Wonderful. I hope you had a great time during the review session, and I would like to see you again next week.
Thanks, Jerry.
Thank you, Jerry.
Perla, I think I figured it out. I'll communicate with you.
Okay.
If you're still there, I think what I was doing wrong on the overflow bin is I was clicking on the x-axis data points versus if I click on a bar and then right click and go to format data, then it shows the bins.
Oh, okay. So it depends on which part you click. Did you mean you click the bars, then it shows, but if you click the axis, it doesn't?
For me on a Mac, yeah.
Oh, interesting. Okay, I didn't know that there's such distinctions. But I also know that if you go to click the bars in a histogram, then go to format data series. Okay. I think in my case, I still need to use the horizontal category access.
Huh. Well, because mine just says overflow bin and underflow bin.
Ah, okay.
I don't know. Okay, I don't see exactly what you see.
Really?
But
Oh, interesting. Okay, there might be some differences between different versions of Excel, but the idea is the same.
so like
when it,
bin width, it says 0.01, but if I go to 0, it like really messes up the formatting.
Then for me, it doesn't even allow me to go to 0.
okay.
That
Jerry,
dramatically
how-
changes. Yeah.
Jerry,
you-
how particular are you going to be with the gaps when we turn
Oh,
in the histogram?
Oh, okay. Well, one good part I forgot to discuss. I won't be the one to grade your homework, so I don't. And don't worry about these small details. It's what's important is that you understand how to build a histogram, how to change some of the settings. But yeah, I don't think it's worth struggling with those small details. If you find that, for example, these bars, there are some gaps. Was it what you were talking about? Then it's quite okay, like this.
Okay.
Thank you, Jerry.
Thank you so much.
My pleasure.
Jerry.
Well, yeah, I hope the first day of the week has been good for you. And I hope to see you again next week.
Hey, Jerry, I have one question.
Oh, hi.
In regards to the
Mr.
tree
Michael.
maps,
Okay.
how often do you have to water them?
Oh,
I just
good
wanted a smile from
question.
you. There we go.
My good one is that it's been raining these days, so luckily I don't have to
good
water
answer.
them at all.
Good answer. I love it, Jerry. Thank you very much.
Yeah, to be honest, I've never used tree map myself, so I don't know how useful it is. Yeah.
You have a good night, sir.
Same here. Yeah, next time we have additional time, I can show some of my favorite descriptive charts that I commonly use.
I think seeing applications of your work would be really useful.
Oh, okay, wonderful.
Yeah,
I will try to see
maybe
whether.
it will be an add-on. Like we still need to go through homeworks and kind of learn the material, but it would be maybe an add-on if we can add like 10-15 minutes, or if you have more time at the end, if you could include them, that would be awesome.
Oh, sure. I will try so.
2 thumbs up on that my end.
Yeah, although I've never used tree maps, I had to build lots of somewhat more complex charts myself. But a good takeaway that I have got is that it's usually not necessary to make charts too complex. Your readers, they want simplicity, so don't try to challenge their understanding of complex charts.
So you're grading our exam, but you're not grading our homework.
Correct. Yeah.
Okay.
Yeah, but the rubric would be very similar. So if you earn very good grades in homework, you should be very good with the exams.
Some of Excel is difficult, especially for Mac users.
Mm-hmm.
One challenge is sometimes I finally find the correct answer, but then I can't repeat it if I didn't take notes.
Okay, I
It's
see.
so-
So my
so many
suggestion
clicks
to
find
that
out.
is that the best way to find out the exact answer is simply to use search. So you go to Google and say Mac, Excel, and for example, histogram, then usually comes up with very good resources of step-by-step instruction.
Appreciate that. And thank you for inserting those links for us. We really appreciate it.
Yeah, I hope it's not too much burden if I include additional resources. Sometimes less is more, but in statistics, there are also lots of occasions that you find students have both motivation and capability to absorb more than what they have already learned in courses.
Excellent. You have a great day. Thank you.
Bye, everyone. See you next time.
Thank you. Bye.